You have any questions?
No, Jalaj.
Okay. So what's the topic today?
Jalaj, I have one question. Right, I've seen some previous section. DynamoDB. So we are using URL only, right? But in real time, we will be using URL or CLI. If CLI means how it be differentiating?
URL or CLI? Come again, please, with the question.
No, like in real time, mostly you'll be using like a script only, right? Passing the if you use Unix server, you'll be just submitting the script, right, to create the tables. Whatever you see now in DynamoDB,
Unix.
yeah.
See, it's not Unix. It's script. It's a cloud. What you say? It's infrastructure as a code. They might use CloudFormation or Terraform.
Okay.
Something like this. Terraform code to create lines. Something. So this is a mostly work of DevOps engineer to maintain scripts, and yes, it can also definitely create by this console as well. So it depends on project to project, like how they are doing. So if I just give you example uses something like this: resource DynamoDB table, your table name, okay, your billing mode and capacities, add all the attributes that you want to create. This is a Terraform script.
So this is like a JSON, right?
Yeah, it's kind of a JSON only, but not. I mean, yeah, you can say it's kind of a JSON only, but it has its own parameters. It has its own syntax.
So this will be done by DevOps team or by developers?
Mostly by DevOps team.
DevOps teams, okay. So mostly developers will be creating the DDL sectors kind of thing only, right?
Yeah. I mean, see, we usually don't use DynamoDB too much. See, it's very rare to get some real-time projects. Okay,
Yeah.
like you also see, no, like how many use cases of real-time data engineering you have. So it's stock market analysis, maybe a flight sensor data, maybe some I mean, it's very less use cases you have for real-time, like credit card fraud reduction. So those kind of use cases, those kind of companies only use real-time data. Some gaming companies. So that's why I know, I say DynamoDB, if you want, you can learn, you can write it on your resume. But this is something you can skip as well. Like from this point onwards, like DynamoDB and Kinesis that we are going to start today, that is something you can skip as well. Okay, focus mainly on Python, PySpark, SQL, Redshift or Snowflake. Okay, master one of those two, Redshift or Snowflake, and AWS Glue Lambda functions. That's all, and S3 as well. Okay, S3 is like very basic and very mandatory.
Okay.
Okay, so let's get started. Today's topic is AWS Kinesis data streams. I have it on type. Okay, as I was saying, see, they're saying in the in the companies or organizations or in the data related projects, as old as data gets, it loses its value. Okay, so that basically means if you can analyze your data as much as faster, it is going to give you that much value. Okay, now if I give you example of flight sensors data, okay, let's say we receive some live data from flights. Okay, let's say we are working for some airlines company. Those have some sensors, obviously, like airplanes have thousands of sensors on boarded, and they all send some data back to your servers. So if you are receiving that data on daily basis, you are collecting it, and then you're processing the data in the evening or in the night to check the health status of the aircraft. Obviously, it is not going to make much sense. Like just assume a very worst case scenario. a flight on boards, it had some issue. Sensor reported those, and you are waiting for the night to get that analyzed. And due to that issue, flight was kind of had an some accident or some issue happened. Okay, so your idea was to avoid such unfortunate events, but your data was not, or your pipeline was not supporting that part. Okay, so how we resolve this? We resolve it via real-time data processing. Okay, that basically means as and when your data is generated, you are going to analyze that and you are going to take actions as much as fast possible. Now, this process of receiving data from those sensors, cleaning it, analyzing it, and creating some dashboards or sending it to some consumers is taken care in AWS world with the help of Amazon Kinesis data streams. Okay, or you can simply say AWS Kinesis is the tool that you can help you to do this process. It is fully managed. It does not require any servers. Its capacity can be provisioned or on demand, okay, as per your requirement. It can auto scale, and it has very high throughput for read and writes. Okay, it has very less response time. You see a real time data. Okay, so this is we are trying to solve like real time approach and data. Now, Kinesis have, you can call it a Kinesis family, where Kinesis has three options for you. The first option is Amazon Kinesis data stream. The second option is Amazon Kinesis Firehose, and third option is Amazon Kinesis Analytics. Now it is also known as Amazon Kinesis Flink servers. Okay. Okay. So data streams. What is data streams? Okay. Data streams. I mean, let's open it. Then it will be easy to go through it. Okay, as I was saying that you have three options of those. Okay, Kinesis data streams, Kinesis data firehose, and managed Apache Flink, formerly known as Kinesis data analytics. I mean, here earlier they were having SQL servers behind the scenes, and now they have Flink servers behind the scenes. Okay, and obviously Flink is more faster than SQL servers. And as the definition says on the smallest of one, sorry, as the definition says on this page, your data streams are supposed to collect and store the streams data. Okay, this is like you are generating some data on some servers or IoT devices. You are collecting those and storing it. See, when you send some data, you need some channel to send the data. Okay, like if I am sending some messages to you, I'm using WhatsApp. That WhatsApp is picking up text from my phone and sending it to you, your phone. Okay, that is also a real-time you can say example of data transfer. Okay, so same channel, sorry, same channel here in this case is Kinesis data streams. It is picking up the data, okay, and it is sending data to your AWS tools. Now you can store it on S3, DynamoDB, or some Redshift. It is your choice. Okay. Second option, Kinesis data firehose. Like say you collect some data and you want to do some modifications over that. Okay. You pick some data and you want to do some modifications over that. In that case, you will use Kinesis data firehose. Now there are two ways of using the Kinesis data firehose. either you can connect this to your IoT devices data directly. Okay, you can configure your IoT devices directly to send the data to Kinesis Data Firehose, or you can install Kinesis Data Streams agents on your source devices. Then you will use data streams to collect the data, and data streams will send the data to Kinesis Data Firehose. Okay, they will not store on S3. They will send it to Kinesis Data Firehose. Firehose will transform the data for you as per your logic. Okay, and then it will either like after that also you can either store the data into S3s, or you can send it to some dashboards on Power BI, Tableau, or quick site. Okay, as per as per your BI tool, or you can send the data from Firehose to Apache Flink servers. Now, Apache Flink server is a piece inside this Kinesis data streams that can allow you to write some SQL queries where you can analyze the data in real time. Okay, so how it actually works is, if I just give you a very small brief, see how we work in batch. Okay, how we work in batch data. We collect the data for a day, and then we write SQL queries over that. Here what we do, every minute we will get data, okay, from like every second, okay, every second the data is being collected by Kinesis data streams. Firehose will accumulate the data for a minute or 5 minutes or whatever the time that you put in there. Okay, minimum is 1 minute. It will collect the data for 1 minute in the Firehose, and then it will transmit the data on Flink servers. Whatever data Firehose transferred to Flink servers in a minute, that data will be analyzed, and you can write queries over that data. So this real-time processing is also known as micro batches processing. Like that means you collect the micro batches of your data, and you try to solve that in real time. So from most left to most right, maximum you will spend is 1 minute, 30 seconds or 20 seconds max. Okay, you can further reduce it. You can further reduce it down by some optimizations. Okay, so this is the introduction of Kinesis, its approaches, and its three tools or three options that we have. So think about it, and if you have any questions, do let me know. Okay, so I hope you have no questions till here. Okay. Okay. So yeah. So this is what I have in introduction. So it says some benefits. I already mentioned it to you. It's real time. It does not take too much time to send and receive your data. It's buffer time. It's process streaming data. It's almost in real time. Okay, it just takes seconds or minutes instead of hours or days. It is fully managed, or you are not supposed to do any configurations, management, or handling of the servers. Okay, and it is scalable as per your demand. You can scale it up or down as per your demand. Okay, then high level architecture, as I was saying it to you, you have sources of data generation in your left hand side. That can be some, I mean, here it says EC2 instances, but that can be some servers. Server in the sense some machines that is generating some data. Okay, it can be your client servers, it can be your mobile phones, it can be your IoT devices, or any sensors or anything that generates data in generate, or anything that generates data can be your source. Okay. Now, from all these sources, data is sent over Kinesis data streams, and as I was saying, the channel to transmit data from one place to another place is actually Kinesis data streams. Okay, so here you have Kinesis data streams. It simply captures the data and send it to AWS services. Okay, then you can send it to S3, DynamoDB, Redshift, EMR, or further to Firehose or Kinesis Analytics as per your choices. Okay, so this is how basically it works like. Okay, so your channel in between is only thing that you have to learn. Okay, some terminologies used in Kinesis data streams. Data stream, I mentioned it to you. It's a channel that transmits the data from one place to another place. Data record, that is the actual data or row or information that gets passed on to that channel from one place to another place. Capacity mode, we all know about this. Provisioned or on demand. Provisioned basically means you're going to provision some capacity. Retention period. Okay, so see, not every time your writers and your readers will have same speed. Okay, so it might happen that these servers are transmitting data and they are placing it here. Okay, and then this data gets read from this Kinesis data stream to some source. Okay, now in this process, let's assume your receivers are not up to the mark with the speed of your senders. In that case, what will happen? Your data will get start residing here. Okay, so the max time data record can stay on your data streams is your retention period. By default, it is 24 hours. Okay, if you want more, you have to pay more. That's a very simple thing in AWS. Okay, so what will happen? Let's say something comes up here and no consumer has picked it up due to its busyness or slowness. Then by default, after 24 hours, it will get deleted. As simple as that. Then you have producers. Something that produces or generates data are called your producers. Consumers, something that consumes your data is called your consumer. Then we have shard. Shard is nothing but some you can say part of data stream. Okay. So what happens, guys, when you go and on console and try to create a stream? Okay, let's do that. So I'll say here I want to create a data stream. Okay, then you have capacity mode. You can choose from here. Then okay, and okay, it's actually here provisioned. Then it asks you for shard, estimator. So you can compare this thing something with your read capacity units and write capacity units. Okay, so basically when you choose a provisioned mode in your Kinesis data streams, you can choose how many shards you want, and as you can see, it has 1 megabyte per second or 1000 records per second read write capacity and 2 Mbps or 2000 records per second read capacity. Okay, so SAD is nothing but it is a unit of your stream, and you can say collection of shard is called as your data stream. Okay, so if you enhance the number of shards, obviously your cost is also going to be increase. Okay, max you can have 200 shards. If you want more than that, you can request a ticket to AWS. Okay, now we have gone to shard. Then we have partition key. Again, on these shards, data gets partitioned. Okay, so shards are going to look something like this. Okay, you can see small pipes in the channel. So let's say if you have 10 shards and you choose a data partition key of city, so might be one shard having too much of data and other shards having very less data. So again, same concepts that we have learned in Spark, that we have learned in Redshifts, partitioning on all those things. It's everywhere same. Choose your partition key that can divide your data almost equally on all the pieces that you have, whether it's a cluster node, whether it's a clusters, or whether it's a shards. It is same concept everywhere to divide equally. Okay, that is your partition key. Then you have sequence number, so which basically what it happens when you share a record on these shards, you can associate a sequence number with your records. So if you want them to be received in sequentially, you can use the sequence number here. So I mean, what I'm trying to say here is, let's say you are processing some orders. If you want to process those orders in a sequence, in a particular sequence, then you will use the sequence number, otherwise you will not. And see, I know most of the things from this sheet you might not get it completely right now, and if you don't get it, it's completely okay. Okay, I'm not saying that you should understand these things uh, just now. Okay, you can go through, explore, and we will have some hands-ons. Then it will be much more much better than this. But again, I'm repeating, if you don't want to master this, completely skip this. Okay, as this is in the course I'm teaching you, that's all my motive is. But yes, if you have some questions, doubts, those you can definitely ask me. So I'll just stop here. If you have any questions, let me know.
Jalaj, those regarding those producers, right? So those things also will be written in Kinesis server itself.
No, that is, let's assume that you have some server. Okay, actually that example we are going to do. Let's say your laptop is generating some data. Okay, it can be any data. So you'll have to install and configure a Kinesis agent there, and that you'll have to write a code there. I mean, agent basically means you'll have to install Kinesis SDK. Like we install Java, Python, all those things. We have to install Kinesis there. That's all.
Also, Jalaj, in like this producer, right? It will be creating in key value things, or how it will be the data? I mean, history
It's
generally.
value pairs only.
Okay.
Okay. So then, as I mentioned, open the CMD, not Anaconda prompt. My bad. We have to open command prompt. Okay, open the command prompt and type this command python -version. It is, I think, yeah, hyphen version. It is. Yeah, you have to type python -version to make sure that you have installed Python in your local systems. Okay, then type AWS. And type version. Okay, this is going to give you one information that you have AWS CLI available with your local machine. Okay, to get installed the CLI, you have to say here on the Google install AWS CLI. Click on this link. Then go on Windows, and here you'll have the download button option. Okay, just click on this link, and it will start the downloading for you. Download and install that thing. Once you have downloaded, install that, you will be able to receive the same thing. Just you have to restart your machine. That is all. So these two things you should have with yourself. Okay. Then what you have to do, you have to come on IAM. And if you remember from the first few classes, I told you that we can create a third-party user as well. Same thing we have to create now. You have to say create user. You will say Kinesis user. No need to provide any console access. Click on next. Attach policies directly. Now the policies that you need for this particular demo, you will need Kinesis. Okay, you will need Kinesis analytics full access. You will need, actually you simply say Kinesis full access. Okay, that is all you need, and you will also need S3 full access. Okay, but what I suggest, so just in case future, if you want to try out more things, simply use admin and use administrator access. Click on next. Okay, no need of full access if you provide admin access. Okay, click on create user. That's all you have to do. A user will be created. Go on that user, and then you have to go on security credentials. you have to go on access keys and click on create access key. Click on other and click on next. Provide some value. Click on create access key and then you will get your access key listed out like this. Okay. Once you get this, and remember this is only going to be one time, so download the CSV file. Otherwise, you'll have to go and delete this key and create a new one. You will not be able to retrieve these keys if you lose them. Okay. So what we have done, we have created a IAM user that is going to be third-party user and that has complete access to your account. Okay. Now here on your CMD, you have to type AWS configure. This is going to ask you for access key ID, copy and paste it here. Okay. Then it is going to ask you for your secret access key, copy. This is going to ask you for a region name. It's obviously you will not have any region name here. Type your region name and press enter. I have already it here, so I'm just going to press enter like this. I mean, all you have to say AP South like this, and format JSON. That's all. Okay. To verify. Okay. See what we are trying to do now. Right now we are trying to use our laptops as a machine or as a device that can send data to AWS Kinesis. Okay, so our laptops are going to work as both producers and consumer for this demo. So for that, obviously, we need some authorization to connect with our AWS account. Same thing we are trying to achieve here. Here you have to type AWS S3 LS. That means on AWS, on S3 service, list everything. If you write this thing, you will get all the buckets that you have in your account. Okay. So if you want to list the bucket, delete, I mean, see whatever action that you can take from console, same thing you can take from here as well. Okay. If you want to enhance your expertise in this area, simply say SD command to delete or do anything. Okay. On Google and you will get those commands. No need to learn and memorize these things. It is not your duty. If it is in some project, you will learn it by default. Now, once we have this thing, I have one Kinesis script with me. Okay. I have one Kinesis script with me that all it does, it sends some records to your Kinesis data stream and then it receives the records via different stream. Okay. So this explanation I'm going to make it tomorrow because it will take its own 30-40 minutes of time. Okay, just wanted to let you know that you can set up your computers like this, and then we will learn about this script and we will perform this script. We will create a stream and going to do some hands-ons there. So then it will be more clear. But before I close this today, if you have any questions, you can let me know.
Jalit, so we'll be using Python only, right?
Yeah, it is Python script only.
Okay. Also, one more thing, for any Python we're using with AWS means we need to use Boto. General Python script.
See, Boto is just to connect with AWS services. So if you're connecting or working with AWS services, you'll have to use Boto. If you're running a generic code like we used to do it in our one of the project, then you no need of that thing.
Also, now the CLI we ran it now, right? So one time if I ran CLI, those keys it will be registered, right?
Yeah, it is kind of registered. You can always use this. See, if I wouldn't have done that part, still I would have been able to run the S3 LS command because it's already there for me.
No, I ran the AWS S3 actually, so my bucket got listed.
But before that, you'll have to install Python and you have to install AWS CLI. Okay. Otherwise,
Yeah,
it will not.
no, it's working for me. Yeah, that's right.
Okay.
I thought for each one we should create one thing. That user you created, right? So earlier I think while S3 I was able to query it. Now I created only for the admin and with Dynamo whatever we created. But still I'm able to access that this thing actually. S3 bucket also.
Yeah, I will say we have now created admin user now, so it will have everything on your account. That's what I said.
Okay. So I can
Users,
use the same thing for Redshift everything, right?
yeah, that user you can use for anything, anything in your account.
Hmm.
And obviously in productions or in real time, you will not have such users. Huh? So do not say that we had an admin user.
Oh, okay.
It's never going to be like that.
But real time we won't be like an root user itself, right? We'll be an IAM user only, right?
It will be IAM user, and obviously it will not be on root user, and it will not have admin access.
Hmm.
Only required things will be there.
And one more thing, so if we have steps, right? AWS steps, one step.
Step functions, you are saying?
Yeah.
Actually, we have discussed about those in one of the class. If I just, it's a kind of, it creates a flow for you. Okay, let's just see. Say you have some 5-6 Lambda functions and one or two glue jobs and some crawlers. Okay, that you can actually schedule with the help of step functions.
Okay.
So we click on get started. Choose create your own arm. That's better. You can say invoke Lambda function. Okay. Then you can design a flow. Choice flow, parallel flow. Let's say you say parallel. Like once this Lambda function completes, you might want to run this two functions and like those some glue jobs or actions you can choose from here. SNS, ECS, step functions, glue job runs. You have multiple actions here.
Okay. This is kind of an orchestration, right? So we can say or what?
Yes, orchestration only. I mean, there's nothing to learn about this. It's just you have to understand these things. That's all. Actions, patterns, and flows. And behind the scenes, it generates JSON for you. That's all. So something somewhere like we had this option to see the JSON as well earlier. No, I don't think that we have this option now. Yeah, it is here on the main page itself. This is the code. So earlier you had to write these scripts. Okay, it was like you cannot design those. You have to write such scripts. Now you're getting it drag and drop only. So that's I mean one error is because I have just dropped it and but I haven't mentioned what to do after this.
Okay.
If you want, you can very confidently say that I used to write step functions, but that is not to add any value. See, let me just write it down for you. All the interviews that I have given till date, okay, that have Python, SQL, PySpark, okay, to what your project idea, okay, warehouse, Redshift, Flake, Lambda functions, AWS glue features. So you can say 20%, 30%, 20%. Okay, this is like your major topics. 70% will be from here. Idea and this is, I mean, you'll have, obviously you'll have this in every interviews, so I can keep it aside. Like you have to mention in your CV. Okay, then you can say 10%, 5%, and 5%. This is how is going to be your interview structure. So if they ask you 10 questions, chances are 2 of them are going to be Python, 3 of them are going to be SQL, 2 from Spark, 1 from Warehouse, and some questions from Lambda or Glue if they are in mood.
Okay. I have 2 more questions. So regarding the question you have showed, right? Actually, I saw this entry question which you was mentioning on day before yesterday. You're on 4th one, right? You're migrating 10 TB of data. So when you say this one, right? So we are migrating either from Oracle or something. So the idea is, I'm asking is, we don't have any direct connector, or we need to pull the data from a legacy to S3 using the PySpark or those stuff, or you have any other default way? Normally, if you
There
go
is
with Azure,
DMS.
right?
In that case, you have to learn about DMS.
Okay.
All right, not this TMS. Let's call it AWS TMS. Learn about this thing. Data migration service. Watch some YouTube videos or some basically this is how it works. You have databases on premises mostly. You connect it with your data migration services. These pulls your data, okay, and it places on S3 mostly. They are saying Aurora, but no, it can actually place on S3. It can place on your RDS as well. Some tools or some source. What I'm saying. See, it can pick data from your databases and it can place it to S3. That is first scenario. Second scenario is that you have created a same database or some other version of the database on your cloud. Okay, that is using RDS service. There also it can go and copy paste. But in 70 to 80% of the project, it's going to be S3 only. Okay, and it has 2 theories. Okay, or you can say it has 2 approaches. One is heterogeneous migration, in which let's say you have Oracle here and you are migrating it to Aurora DB. In that case, it is going to be called heterogeneous migration. That means your source DB and your target DB is different. Then you have homogeneous migration. It's as simple as that. You have same database on premise, you have same database on cloud. That is your homogeneous migrations. Okay, that is one way of handling the data migration using data migration service. Same way you have other third-party tools. So I had Talent with me. That is not now. Let me check if I still have it.
So there'll be a project like in just for asking for resume level. So there'll be a project like migrating the Teradata to Redshift or Oracle to Redshift.
Mostly these things only.
Okay.
See, I have worked on. See, if I say now, only one project I have worked on data engineering. That was an Accenture. Other two projects, they call themselves data engineering, but it is more or less data migration project only. Okay, not much of transformation work. I mean, right now though it's almost copy paste from source to target. In my previous project, which was like 6 months back, I had some transformations, but mostly these guys are simply doing transformation from your legacy to your latest thing. Okay, and see why data engineering is in more demand than data science or AI or in all those things, because right now it is saving cost for you. All these DB2s, Postgres, Oracle are very, very costly. And all your ETL tools like Data Stage and IBM Teradata, IBM Data Stage or Teradata, these are very costly tools. So, and they are not also so capable also, okay? So they are just moving to more capable and more cheap options. So I had just one job here that does a very simple thing. It connects to your local file system and it outputs the file on cloud bucket. Okay, so if I execute this job, it is going to pick a file from my source and it is going to place it on S3 buckets. So here I have used tfile input delimited. If you use some database connections, it will read the data from your on-premise database and it can transfer it to your cloud. So idea, what I'm trying to say is you have multiple options. You have DMS, you have third-party tools, talent, and multiple other tools that can do this data migration for you.
Okay. Oh, new tool came, right? Militant something.
Every day there's a new tool. There's no limit and it's endless. Like what your project choose, it depends completely on them.
Okay. So we have a AWS data lake, right? So nothing but a combination of all the things. So for when you're going to create, right, you'll be using this option AWS data lake, or you just create the S3 bucket or stuff.
See, data lake is on S3 only. See,
Yeah,
if you see this thing, what is a data lake? Okay, if you read this thing, it simply says.
No, I'm asking about that option actually. In AWS, we have a AWS data lake on particular this thing actually. So inside that, if you see means, we'll be creating the number of S3 buckets and we'll be identifying a source.
Okay, you are saying about AWS data lake here.
Yeah. Data lake.
AWS lake form. Yeah, this is also the same thing. See, if you see this thing, you are only landing on the glue thing only. So basically, if you see, it's glues data catalog and your data is going to be on S3 bucket only. So basically, lake form is what it is doing, just creating meta information for you on your data stored on S3 buckets. That's all. So no need to learn about this thing also. Yeah, one thing that you can learn add up in this thing part is, I mean, after SQL, you can say data normalization, SCD, dimension.
Will you be seeing SCD type 1 and type 2 in Redshift or Snowflake?
Yeah. I mean, see, SCD is something that you can perform everywhere.
Yeah. So the Redshift, why I'm asking, right? Generally in Hive, if you see, right, we can't do upgrade actually. I mean, update the records. So the type of STD type 2 doing in Hive table is different. Whereas if you go to Teradata Oracle, it will be like just to write an update script.
Yeah, same is almost for Redshift. There's, I mean, you can definitely do updates here, but the way we handle it here, it's a bit different.
Okay.
Not exactly at Hive, you can say, but it's slightly different here. Actually, that is what we are going to do in our final project. We are going to perform a SCD2 code. Okay. So actually, in my final project, I'm not doing any blah blah transformations. That how to replace, how to null, how to write case statements. My approach is to share the concepts with you. Okay, how a project's code looks like. Okay, all the transformations, all the joins, and all those things you can practice. Download some data and practice there.
Yeah, sure.
But approaches is something that we are going to discuss.
Okay, sorry. Thanks.
What are they going to ask in Python, Jalis?
Python, see, okay. I think I should have some questions. Okay. Oh, not this, not this. Snowflake database, Python. I mean, last time they asked me questions like this. She shared me a dictionary with me and asked me to get those columns or something. Okay, that I want to. I think I shared that with you in some class. That how to retrieve the URL1, URL2, and where environment is prod. Mostly they are going to be asking about list and dictionaries. Okay, checking your knowledge on for loops. How will you utilize those? Some if else conditions, some scenario they'll give you, and you'll have to code that. And same thing goes for SQL only. Okay, they will give you one or two tables, maybe write some joint statements or give some scenario based questions. And I want to fetch these records based on this condition. So that all you have to do in this thing.
Okay, and regarding the project, right? So I have not worked on project which uses all of these services.
Okay, what you have worked on, what you do right now?
Right now, it's a different thing. It's like a reporting project. So we are
Ah,
using a different tools. We're
just
actually
tell me.
using a data virtualization tool. It's called Denodo.
Okay, then what you do on daily basis?
Yeah, my most of the work is on this Denodo tool itself. So we are connecting to different sources, Oracle, MySQL, SQL Server data. We're
Mhm.
connecting it to it, and we have created some views on this Denodo tool, data virtualization tool, and we have this standard format which client requires. So we are fetching the data and we are like SQL thing. So views we are creating all the joins and everything, and on daily basis we are generating these reports and we are sending it to a different source. And for jobs and everything we're using Tidal.
So it's done, right? It's all sorted for you, Ashwarya. See, simply say
But
we
this I have to
have,
apply for AWS, right? Because
yeah, that's
I
all.
should tell them that
We
I've
have
worked on this.
many sources. See, like I'm adding it for you. We have many sources as you mentioned. Write the sources name, and we pull them on S3 using DMS. Okay, as simple as that. If you can learn DMS yourself, it's very simple. Say that it's done by me, otherwise say it's ingestion team. Then where your responsibility starts, you create AWS glue jobs, okay, and in that you write PySpark scripts, okay, to join, calculate, transform data, and send on S3 in Parquet format. Then they'll ask you why Parquet format. Just explain them. It is much more optimized than your CSVs. I think I have given an example of row-based versus column-based file formats. You give that example to them that how it is more optimized. Okay. So here you are explaining that you use PySpark, Python, SQL, and all those things. Write this into S3 and then copy data into Redshift. Okay, let's say you use Redshift. Here you can say we write SQLs to create views. Okay, and then this goes to BI for analytics, and that's all. Now in between, if you want, you can add Lambda functions here. Lambda functions to trigger and monitor glue jobs, copy data. I will copy basically back up the data and converting ad hoc requirements to automation. That's all. Just if you just pick this up, ChatGPT, say I want to write points on resume is what I do in my AWS cloud project as data engineer. Okay, just use this, type it. That's all you have to say to just copy paste this on your resume.
Okay, so if there is anything like any analysis we need to do, then I think we should say on Redshift we can query, right? So
Yeah.
and also Athena, you mentioned Athena. There
See,
also we
don't
can
mention
query.
everything. Then they'll ask you why you use Athena also, why use Redshift also. Choose one of them.
Okay. Okay.
If you are choosing one of them, stay on that and prove them why it is needed for my project.
Okay.
Jalaj, Athena is not a DBMS, right? Actually, so RDMS is right. Anyway, we need a blueprint, right? So we'll be creating a crawler, right?
Yes. So Athena is not used everywhere. That's what I'm saying. If you're saying that you use Athena, then you have to justify why not Redshift, why Athena. And if you're using Redshift, not Athena, then you have to justify that also. See, justification. Why is the most important thing in the cloud? Why you use Redshift? Why you use Athena? Why you use Snowflake? Why you use Glue? Why you use Spark Shell? Why do not Python Shell? Okay. Why not the drag and drop of the Glue thing? Why is the most important answer here? Not what. What everybody knows. Like what is AWS Glue? What is Redshift? What is Snowflake? Everyone knows that.
Yeah, no, I understand that. Just asking, like, see, Athena is for real-time querying, and like if you want to suddenly see the data what is in S3, so then only I will go Athena, right? Otherwise, like Redshift is completely storing the DB data, right?
See, if you only give this expression to any interviewer, he'll next question he'll ask that we have Redshift Spectrum. Why don't you use a Spectrum to query S3 or databases?
Okay.
So explore these things. I mean, I have already given these answers and explanations,
Yeah.
but explore it from your side as well.
And I have also worked on data bits, so I think it will not be relevant to this project idea I'll be sharing, right?
You can send it, say it not in some different project. Instead of AWS Glue, we had Redshift. Instead of S3, we had ADLS of Azure. Instead of Redshift, we had Synapse. It will be multi-cloud experience. That's all. Learn a few things about Synapse. Learn a few things about ADLS.
Okay.
Okay, then we'll meet tomorrow and we'll perform the hands-ons.
Thank you.
Thank you, guys. Bye-bye.
Thank you all.